Because the first part of 7.2 for PropStat took longer than 15 minutes, we have to have a second part. So this is what we finished on for the example with the 2000 census. Let's go on to the next screen. So, the Beatles. She Loves You, yeah, yeah, yeah. Nico's a big fan of music from the 60s, and 26% of his songs on the smartphone are Beatles songs. He sets his MP3 player to shuffle so that it selects songs randomly. Assume the shuffle function permits repetition of songs, so the population of songs is essentially infinite. During a long drive, Nico plays 50 randomly selected songs. What are the mean and standard deviation of the proportion of the 50 randomly selected songs that are Beatles songs? The mean and standard deviation of the proportion of the 50 songs. So how do I do that? Well, let's see. The mean, remember, sub p-cap, this is that p-cap is the randomly selected songs, is the 0.26, the p, from the population. The sigma sub p-cap is the square root of pq over n, the 0.26 from the 26% of songs, then 1 minus that, which is 0.74 over n. Okay, we get a 0.0620. Okay. Calculate the probability that more than 30% of the randomly selected songs are Beatles. Okay, so we got to think. We got more than 30%, so we got to start at 30 and go to infinity. So we're going to use, once again, calculator, normal CDF. The probability that p-cap is greater than 0.3. Start at 0.3, go to infinity with a mean of 0.26, standard deviation of 0.062. Gives us 0.2594. So, for thinking percentages, about 26%. That they'd be more than 30% of the songs. Remember, a picture can help you an awful lot. The 0.26 and greater than that, the 0.25. So, that's all we needed to finish off section 7.2. We can find the mean, check for the 10% condition before calculating the standard deviation. I guess, did we even check for that? We got time because this has just started, right? Previous. So 10%, let's see here. Songs. So it says 26% of songs. Oh, I guess the population is essentially infinite. So I guess that means that we are at least 10% of infinity. Or not at least, at most 10% of infinity. So that was okay. We could use those calculations. If the sampling distribution is approximately normal, did we do the NP and the NQ? Just a second. Previous, previous, previous. What's N times P? The N, which is 50, times the P, which is 0.26, like 1/4 of 50. So if you divide that by 4, and I guess that's at least 10. And because 26%, the 0.74, 3/4 of 50 is 3 times what you had before. So yeah, okay. We can use the normal because of the NP and the NQ. Calculate it because it is appropriate. And we're done. See you on the next one, 7.3.